This video will cover a quick review on trigonometry. Right now you could see the three trigonometric ratios that you need to be familiar with. However, you do not have to memorize these formulas because they're going to be given to you during the test on the reference sheet, but you should be familiar with them already. Let's take a look at our first question. Triangle ABC is a right triangle where the measure of angle C equals 90 degrees and AB equals 15 units. Find the sine and cosine of each acute angle. Okay, for a question like this, I recommend you first draw a sketch so that we can visualize what the question is saying. All right, so let's draw a right triangle and let's label the sides ABC and make sure that you put angle C as the 90-degree angle because it says in the question that the measure of angle C is 90 degrees. Then the A and the B, you could put them on the other two angles. Okay, next in our question, it says that side AB equals 15 units. So find side AB, it's the hypotenuse, and let's label it 15. Okay, now it says find the sine and the cosine of each acute angle. In case you forgot, an acute angle is an angle that's less than 90 degrees. There's two acute angles in this triangle, angle A and angle B. So we got to find sine and cosine of angle A and sine and cosine of angle B. So let's first do the sine and the cosine of angle A. Okay, from the point of view of angle A, let's identify the different sides. We'll start with the hypotenuse. The hypotenuse is always the side opposite the 90-degree angle. So there we have our hypotenuse. Side AC is the adjacent side because it's adjacent means next to. And that's the only other side that's next to angle A. And then side CB is going to be the opposite side. Okay? This is where a lot of students make mistakes. They mislabel the sides. And it's something so simple. All right, just remember, first identify the hypotenuse. It's the side opposite the right angle. Once you've identified the hypotenuse, next identify the adjacent side. The adjacent side has to be touching the angle that we're talking about. Okay, so since AB is the hypotenuse, that leaves AC as the only possible adjacent side. The opposite side is never touching the angle that we're talking about. And because we're first doing this from the point of view of angle A, the opposite side has to be side CB, which is not touching angle A. Okay, now that we've identified those sides, let's first find the sine. All right, so sine is the opposite side over the hypotenuse side. So the opposite side is side CB, and the hypotenuse side is 15. And that's it. That's my answer. CB over 15 is the sine of angle A. Now let's find the cosine of angle A. Cosine is the adjacent side over the hypotenuse. Since the adjacent side is side AC and the hypotenuse is 15, I just put AC over 15 and that's my answer. So that's very simple. Now we have the sine of A and the cosine of A. Now let's do angle B. Okay, from the point of view of angle B, the hypotenuse stays the same. The hypotenuse never changes because it's always the side opposite the 90-degree angle. However, the opposite and adjacent sides are going to change now because we're looking at it from the point of view of the other acute angle, angle B. Okay, so from the point of view of angle B, the adjacent side is side CB because it's the only other side that's touching angle B. And the side all the way across from angle B, which is not touching angle B at all, is our opposite side, side AC. Okay, so now let's find the sine and the cosine of angle B. Sine is opposite over hypotenuse. The opposite side is side AC, and the hypotenuse is 15, so that's my answer. The sine of B equals AC over 15. Okay, now let's do the same for cosine. Cosine is the adjacent side over the hypotenuse, and again, they're going to give you these formulas on the exam. You just got to know how to use them. Okay, so the adjacent side is side CB and the hypotenuse is 15. So just put CB over 15 and there's our answer. Okay, so let's put all our answers together so we can analyze them a second. Okay, so our answers are Sine of A equals CB over 15. Cosine of A is AC over 15. Sine of B is AC over 15. And cosine of B is CB over 15. And I want to point out a very important relationship that's going to come out several times in this review because it's very important. Okay, notice that the sine of A, CB over 15, is the same as the cosine of B. They both equal CB over 15 because you end up dividing the same sides to get them. Okay, and the same thing is true with the cosine of A, which is AC over 15, and the sine of B, which is also AC over 15. Okay, so what I'm trying to point out is that the sine of A will always equal the cosine of B, and the cosine of A will always equal the sine of B. All I'm doing is getting the two acute angles, which may have different letters, but the cosine of one will always equal the sine of the other, and the sine of one will always equal the cosine of the other. That's going to come up again several times in this review, and it's very important. All right, question number 2. Triangles JKR and BTM are similar. The measure of angle MBT equals 90 degrees, BM equals A, BT equals B, TM equals C. Write an expression that represents the cosine of K. Okay, let me show you how to approach this problem because it's a very simple problem. Okay, the absolute first thing that you should always do, okay, and by the way, I don't know how many times I see students taking exams and they never write down anything throughout the entire exam, and you wonder why you can't pass the exam. Okay, you have to make sketches, you have to work things out, you have to write. You can't just look at it and guess. That doesn't work. You're not going to guess your way through the exam. Okay, so let's draw a sketch. It says there's two triangles. So let me draw two triangles. Okay, now it says that the letters of the triangles are JKR and BTM. Okay, and also it says that they're similar. So we got to keep the order of the letters the same. So on the left-hand side, let me write JKR, and on the right-hand side, BTM. And I kept it in the same order that they gave it to me in the question. That's very important. Don't mix up the order. Okay, let's go to our next piece of information. It says that the measure of angle MBT equals 90 degrees. Now, make sure you realize angle MBT, the letter in the middle is the vertex. That means they're talking about that angle. It's telling me that that angle is 90 degrees. So I need to adjust these triangles to reflect the fact that angle B is 90 degrees. I'm going to change both of them to turn them into right triangles with angle B 90 degrees. All right, there, I've corrected my mistake. Now I have two right triangles, and on the right hand side, angle B is 90 degrees, and on the left hand side, the letter that goes with B is J. So on the left hand side, I had to make J 90 degrees. Notice that in both of the triangles, J and B are the first letters. That's how I know that those two letters or those two angles are related to each other. All right, let's go to the next piece of information. It says that side BM equals A. So find side BM and let's write a little a. That means that the length of side BM is A. Okay, next piece of information. Side BT equals B. So locate side BT and let's write a little b there. And the last one, side TM equals C. Locate side TM and let's put a C there. Okay, notice how having this drawing makes everything a lot easier to understand. Without a drawing, this looks like very complicated. But now that we've drawn it out, it does not look complicated. Okay, now one thing I want to point out before I continue. In the question, it says that the two triangles are similar. If two triangles are similar, that means that the cosine, for example, the cosine of angle K has to equal the cosine of angle T. And the sine of angle R has to equal the sine of angle M. Basically, the sine, the cosine, and the tangent of their associated angles have to be the same. Always, okay? So let's look at this. Okay, it says write an expression that represents the cosine of angle K. All right, so there's angle K, and the cosine is the adjacent side over the hypotenuse. So let's identify what's the adjacent side and what's the hypotenuse. The adjacent side is side KJ, and the hypotenuse side is side KR. But we don't have any letters there. We don't have any information about those sides. So we're going to have to get the information from the other triangle, because since the two triangles are similar, their cosines will be the same. Okay? So let's go to the other triangle, triangle BTM, and let's identify the adjacent side, which is the side that is has a length of B, and let's identify the hypotenuse, which is the side that has a length of C. So to get the cosine of angle K, I'm just going to use those two sides. Okay, so the answer is the cosine of angle K is going to equal B over C. All right, because it's the adjacent side over the hypotenuse. Now, as you can see, I circled the word expression so that you understand something. Okay, the question does not say write an equation. It does not say that. If it says write an equation, you would have to include an equal sign because the word equation has an equal in it. It says write an expression. So that means your answer, all you have to write is B over C, nothing else. I don't write cosine of K equals blah, blah, blah. No. Since it's write an expression, the expression is B over C. All right, let's move on to the next question. Okay, now this is not a question. This is just a concept I want to go over we're going to review in the next couple questions. All right, it requires you to remember this. Okay, now at first glance, this may seem complicated, but it's actually extremely simple. It says the sine of an acute angle in a right triangle is equal to the cosine of the angle's complement. And the cosine of an acute angle in a right triangle is equal to the sine of the angle's complement. Okay, the word complement is referring to the complementary angle. If you forgot what complementary means, those are two angles that add up to 90 degrees. Complementary is two angles that add up to 90 degrees. So for example, the sine of 60 degrees has to equal the cosine of 30 degrees. Notice that 60 plus 30 equals 90. The same thing is going to be true of all my examples. The sine of 40 degrees equals the cosine of 50 degrees. All I'm doing is putting the word sine in one and cosine in the other, and whatever the number they give you in the first one, the other one has to be 90 minus the first number in order for the two numbers to add up to 90. Okay, so in my third example, the cosine of 20 degrees equals the sine of 70 degrees. Again, notice 20 plus 70 equals 90. Fourth example, cosine of 55 degrees equals sine of 35 degrees because 55 plus 35 equals 90. And at the bottom, I wrote the same concept, but with the variable theta. The sine of theta is going to equal the cosine of 90 degrees minus theta. That means whatever number you substitute for theta in the first part, then in the second part you just do 90 minus that number to get the degrees of the complementary angle. Okay, let's look at some questions that involve this concept. This concept is very likely to come up more than once. Okay, so that's why it's in the review several times. All right, so look how simple this question is. I mean, how can anybody get this question wrong? I'm sure some of you will find a way, but it's so simple that it's criminal to get this wrong. All right, so it says fill in the blank. The cosine of blank equals the sine of blank. Okay, so hopefully some of you are looking at this and you already know the answer. There's two correct answers, by the way. So let me show you the correct answers. The two correct answers are, you could say the cosine of j equals the sine of m, or you could say the cosine of m equals the sine of j. Both of those answers are correct. All we're doing is taking the two acute angles, okay? So those are angles j and m. You cannot use angle k because angle k is not acute, it's 90 degrees. Acute means less than 90 degrees. Okay, so angle j and m. So the cosine of j equals the sine of m, or you could say the cosine of m equals the sine of j. They're both correct. Very simple. You don't have to know any math to answer that. Question number 4. Same concept, same exact concept. Right triangle XYZ is shown where side XY does not equal side ZY. Select all the statements that are true about triangle XYZ. Okay, so this is the same exact concept we just saw in the previous question. All you got to do is take the two acute angles, which are angles X and Z, and make the cosine of one equal to the sine of the other, and make the sine of one equal to the cosine of the other, and that's it. You're done. Okay, now when you look at the answer choices, if you're not sure what you're doing, they could look pretty tricky, so you got to look at it carefully. So hopefully you're looking at them and identifying the answers already. Our first answer is, or actually, there are both of our answers right now. The cosine of x equals the sine of z, and the sine of x equals the cosine of z. All right? Hopefully everyone is understanding that. Like I keep saying, there's a good chance you're going to see questions about this because it's a concept that comes up a lot on exams. Okay, so our two answers are letter B and letter E. Okay, let's move on to question number 5. All right, now question number 5. Now we're getting into the questions where you have to solve for the length of a side that's missing. All right, so we have a right triangle, and the question says a ramp is shown below. Which of the following expressions could be used to calculate the distance from A to B? Okay, so first let's identify the different sides. Okay, from the point of view of angle 23 degrees, we have to do this problem from the point of view of the 23-degree angle because that's the only angle they give us that we could use to use the trigonometric functions. Okay, you can't use the 90-degree angle. So from the point of view of the 23-degree angle, the 28 feet side is the adjacent side, and the side that we're looking for is the hypotenuse. Remember, the hypotenuse is always the side opposite the 90-degree angle. That's the first one, the easiest one to point out if you're someone that gets confused by this. All right, so if you struggle with correctly labeling the sides, I would always start with the hypotenuse. And once you've identified the hypotenuse, the other side that's actually touching the angle that we're using, that has to be the adjacent side. All right, so 28 feet is the adjacent side. Okay, so now let's ask ourselves which trigonometric ratio uses the adjacent side and the hypotenuse side. Okay, that has to be cosine. Cosine uses the adjacent side and the hypotenuse side. So we need to use that to solve our question. And by the way, in this question, we don't actually have to solve it. We just have to pick which expression will allow us to solve it if we had to solve it. Okay? So now that we know that cosine is the adjacent side over the hypotenuse side, let's substitute into that formula the information that we know. We know that the angle is 23 degrees, and we know that the adjacent side is 28 feet. So let's substitute that into the formula. And now we have that the cosine of 23 degrees equals 28 over the hypotenuse. We don't know what the hypotenuse is. That's the side that we're trying to figure out. So let's put a variable there. Let's put the variable x. Okay, now we're trying to solve for x. That means we need to get x by itself on one side of the equation. Okay, so now let's use our algebra skills to get x by itself. The way you get x from the right-hand side to the left-hand side is well, you got to multiply both sides by x, and then move cosine of 23 degrees to the other side and make a division. So basically the shortcut, on this question I used the shortcut method. On some other questions I used the longer method. But the shortcut method, when the x is on the bottom, is that the x and the cosine of 23 degrees basically switch places. All right, so I switch places with those two, and now I have x equals 28 divided by cosine of 23 degrees. And that gives us the answer that we're looking for, all right, which is answer C, 28 divided by cosine of 23 degrees. That's how we could solve for the distance from A to B. All right, question number 6. What is the value of x? Round your answer to the nearest hundredth. All right, so as you could see on the top left, we have a right triangle, okay, and in that right triangle, it shows that the hypotenuse is x. The angle measure that they're giving us is 58 degrees, and there's one more piece of information that we could figure out. Okay, so first of all, here's our right triangle that we're looking at. Let's get that right triangle and let's isolate it. All right, so let's move it over here, and we could figure out by using by using the information at the, let's call it a house. Okay, that the house is 18 feet tall, and the rectangle on the bottom is 12 feet tall. So if you subtract those two numbers, we can get the height of that triangle. Okay, 18 minus 12 tells us that the height of the triangle is 6 feet. Okay, now with that information, I'll be able to solve for x. Okay, let's identify the sides that we're working with. All right, so first we have the hypotenuse. The hypotenuse is the side opposite the 90-degree angle. Okay, and on the other side, we have the adjacent side. Because remember, if x feet is the hypotenuse, the adjacent side has to be the other side that's touching the 58-degree angle. Okay, because that's the angle that we're using. Okay, now that we have that, the question is, which trigonometric ratio uses the adjacent side and the hypotenuse side? You should know by now that we got to use cosine because cosine is the adjacent side divided by the hypotenuse. All right, now that we know that we're using cosine, let's substitute the information that we have. We know that the angle that we're working with is 58 degrees and the adjacent side is 6 and the hypotenuse is x. So let's substitute that into the formula and we have the cosine of 58 degrees equals 6 over x. Now we're trying to solve for x. Okay, so here I'm doing the longer method. All right, so if you didn't get it on question number 5, how that worked when I solved for x, here I'm going to do the long method that explains everything. All right, so first I want to move x to the left. Since x is dividing on the right hand side, I'm going to do the opposite of dividing. I'm going to multiply both sides of the equation by x. When I do that, on the right hand side, the x's cancel out. Okay, so that leaves me with x times the cosine of 58 degrees equals 6. But I'm still trying to isolate x on one side of the equation. So now I got to get rid of that cosine 58 degrees and move it to the other side. Since x and cosine of 58 degrees is multiplying, I'm going to do the opposite of multiplication. I'm going to divide both sides of the equation by the cosine of 58 degrees. That's going to eliminate the cosine of 58 degrees from the left-hand side. So x equals 6 divided by the cosine of 58 degrees. Okay, now that we've gotten to that part, now the next part is very important that you understand how to do that in the calculator because students tend to forget how to do that, right? So this is something that you should definitely practice because if you don't practice on the exam, there's a good chance you're going to enter it wrong in your calculator and that's it. Even if you got this far, if you enter it wrong in the calculator, you're going to get the wrong answer, okay? The key thing to remember is that you always got to, like for the cosine of 58 degrees part, you always got to write the 58 before you hit the cosine button. Okay, so the way you should enter it into your calculator, I'm gonna walk you through it right now. You should enter 6 divided by 58 cosine equals, I'll say it one more time, 6 divided by 58, hit the cosine button, and then you got to make sure to hit equals because if you don't hit equal, it's only giving you the 58, if you don't hit equal, it's giving you the cosine of 58 degrees, which is not our answer. We want 6 divided by the cosine of 58 degrees. So you got to make sure to hit equals. And when you hit equal, you should get this answer. X equals approximately 11.32 feet because our question says to round to the nearest hundredth. So again, when you do that in your calculator, that's something you should definitely practice. You don't want to be doubting yourself on the exam and wondering if you entered that correctly or not because the person administering the exam cannot help you with that. You need to know how to do that before the exam. Okay? All right, question number 7. To the nearest tenth of a meter, what is the difference in length between side AB and side BC? All right, so this question is like 2 questions in one because not only do we have to figure out side AB, we also got to figure out side BC. We got to figure out 2 sides. All right? So let me show you how we're going to do that. All right, first of all, look at the angle that they're giving us. They're giving us the measure of angle BCA, which is 75 degrees. So we got to do everything from the point of view of that 75-degree angle. So let's identify our hypotenuse, our adjacent side, and our opposite side. Okay, let's do that first. So there's our hypotenuse side. It's side BC because it's the side opposite the 90-degree angle. Our opposite side is side BA, which is the side that is completely across from the 75-degree angle and is not touching the 75-degree angle at all. And our adjacent side is side AC because that's the side that together with the hypotenuse creates the 75-degree angle. Okay, now that we've identified the 3 sides, let's start with which side? Okay, we could start by solving for BA, side BA. Okay, now the trigonometric ratio, I mean, you could see it on the paper, but the trigonometric ratio that compares the opposite side to the adjacent side is tangent. All right, the tangent will equal the opposite side divided by the adjacent side. Okay, so let's substitute the values that we know. We know that the angle is 75 degrees. We know that the adjacent side is 12. And the opposite side, which is the side that we're trying to solve for, we don't know. So we're going to put an X there. So we have the tangent, or we could just write opposite. Okay, so the tangent of 75 degrees equals opposite over 12. The opposite side over 12. All right, I'm trying to figure out what is the length of the opposite side. So I want to get the opposite side by itself in that equation. So let's move the 12 to the left-hand side of the equation by multiplying both sides by 12. When we do that, we're going to get that the opposite side will equal 12 times the tangent of 75 degrees. Now, this is another important part where you should make sure you know how to enter this into the calculator. So I'll say the same tip I said on number 6, which is that the key thing is making sure that when you get to the part that says tangent of 75 degrees, you always got to hit the 75 before you press the tan button. All right. I like to recommend to go from right to left because that kind of tells you how to enter it into the calculator, but you could also do it from left to right. I'm going to explain it both ways. If you go from right to left in your calculator, you should enter 75 tan, then you hit times 12 equals, and that'll give you your answer. I'll say it one more time. 75, hit the tangent button, times 12 equals, and that'll give you the answer. If we go from left to right, this is how you would do it. From left to right, you would enter 12 times 75 tan equals. I'll say it again. From left to right, 12 times 75 tan equals. Okay, so our opposite side is approximately 44.78 meters. All right, I rounded it to the nearest hundredth for now because it's repeating, or it's not a repeating, but it's a decimal that continues. So for now, I just rounded it to the nearest hundredth. So our opposite side is 44.78. Let's put that in our sketch. All right, it's 44.78. Okay, now, next what we're going to do is solve for the hypotenuse because we also need to find the hypotenuse. And just a word of advice, there's two different ways that you could solve for the hypotenuse now, but I would solve for it using the 12. Don't use the side that you got 44.78 because let's say you made a mistake and the answer is not, or let's say you made a mistake and side AB is not 44.78. You don't want to use the number that you have there, which could potentially be wrong, to calculate the other side because then that would give you two wrong answers instead of one. So let's use the number that they gave us in the problem, which is the side that has the 12. Okay? So if we do that, that means that we're going to use the adjacent side, which has the 12, and we're going to use that to find the hypotenuse. All right? Again, just to repeat what I was just saying, if I wanted to, I can also find the hypotenuse by finding the sine of 75 degrees, which would involve dividing 44.78 by the hypotenuse. But since we calculated the 44.78, and on an exam, it's possible that we made a mistake. If there's a way to do it without using that number, it's best to do it without using that number so that there's less of a chance of you making two mistakes in one problem. All right, so let's use the adjacent side, which contains the information they gave us, which is that the adjacent side is 12 meters. All right, so cosine is adjacent over hypotenuse. Let's substitute the values that we know. The measure of the angle that we're working with is 75 degrees. The adjacent side is 12, and we don't know the hypotenuse. That's what we're trying to solve for. All right, so there's our setup. Cosine of 75 degrees equals 12 over the hypotenuse. All right, now let's get the hypotenuse to the left and cosine of 75 degrees to the right of our equation. So we multiply both sides by the hypotenuse, which that cancels out. Okay, and then let's divide both sides by the cosine of 75 degrees. So that leaves us with the equation that the hypotenuse equals 12 divided by the cosine of 75 degrees. Now again, let's practice putting that in the calculator. The correct way to enter it would be 12 divided by 75 cosine equals 12 divided by 75 cosine equals, and the answer you should get is approximately 46.36 meters. Okay. Okay, now look at the question again. The question says to the nearest tenth of a meter, what is the difference in length between those two sides that we just found? The difference means you got to subtract. So to get our answer, we have to subtract those two numbers. All right, so let's go ahead and do that. 46.36 minus 44.78. So the difference between side AB and side BC is 1.58. And the question says to round to the nearest tenth of a meter. That means they want one digit after the decimal point. So our final answer is going to be 1.6 meters when we round to the nearest tenth of a meter. All right, here's our final question from this review. Question number 8. It says Daniel travels from his house to his school. After school, he travels to the gym to exercise. What is the measure of angle X to the nearest degree? All right, so we got to find what is the measure of angle X. Okay, now we haven't done what we're about to do in this entire review. All right, so let me point out something. Whenever you're trying to find the measure of an angle using trigonometry, all right, so like in this question, we're trying to find out how many degrees is angle X. That's when we have to use those inverse buttons. The inverse buttons, if you forgot what that is, those are the buttons that say sine -1, cosine -1, tangent -1. All right, the correct way to refer to those are the inverse of sine, the inverse of cosine, and the inverse of tangent. We only use those buttons when we're trying to find the measure of an angle, which we're going to do in this question. All right. All right, so here we go. First, let's identify the different sides. There's the hypotenuse. Again, the hypotenuse is always the side opposite the 90-degree angle. Okay, now from the point of view of the angle that we're trying to find, which is angle X, this is the adjacent side. All right, it's the side that together with the hypotenuse side forms angle X. All right, so the adjacent side is 1.28 miles, and that leaves the other side on the complete opposite side. That's the opposite side, the one that says 2.75 miles. It's the side that is not touching angle X at all. That's the opposite side. Okay, so now that we've identified those three sides, look at how from the point of view of angle X, what are the two sides that they gave us? They gave us the opposite side and the adjacent side. So that tells us which trigonometric ratio we have to use. Okay? Which trigonometric ratio uses the opposite and the adjacent side? That has to be tangent. Okay? So the way you figure out the measure of this angle is the way that I wrote it, which is that the measure of angle X, and by the way, when I taught this to my students, okay, in case you forgot, I recommend that you write it my way, because the way that I'm writing it tells you exactly what are we looking for, and it kind of tells you exactly what to do in the calculator. So I highly recommend that you write it this way. So what are we looking for? We're looking for the measure of angle X. So my equation says the measure of angle X equals the inverse of tangent, parentheses 2.75 divided by 1.28. Why am I writing 2.75 divided by 1.28? Because tangent is the opposite side divided by the adjacent side. So the opposite side is on the top, the adjacent side is on the bottom. And again, whenever you're looking for the measure of an angle, you have to use those buttons that have the -1. Okay, so now that I've written this out, let me tell you how to enter this into the calculator. Basically, you have to do what's in the parentheses first, and then you have to hit that inverse of tangent button, which remember that to access those buttons, in most calculators, you first have to hit the second button. The button that says 2ND, second, which stands for the secondary function. Okay, so in your calculator, you should do 2.75 divided by 1.28 equals, then hit the second button, and then hit the inverse of tangent button, and that'll give you the answer. I'll say it again. In your calculator, you should do 2.75 divided by 1.28 equals, then hit the second button, and then hit the inverse of tangent button, and that'll give you the answer. The answer you should have gotten when you rounded to the nearest degree is approximately 65 degrees. And that's our answer. All right, our answer is that X is approximately 65 degrees. All right, that concludes this review on trigonometry. Make sure to subscribe to my YouTube channel. More videos are coming that are really going to help you on your exam.